Hello everyone, this is Mr. Appel, and today I'm going to show you how to use your graphing calculator to use parametric equations and switch into parametric mode. And I'm going to do that by doing a couple of the problems from your homework that you were working on. So we'll kill two birds with one stone here. Alright, so this first problem says baseball hits straight up in the air from a height of 5 feet, initial velocity of 80 feet per second. So first we're going to use an equation to model the ball as a function of time. So whoops, let's try that again. So the height as a function of time is going to be, it's feet per second, so that's negative 16t squared. Initial velocity is 80, so that's plus 80t. Initial height of 5, so plus 5. So that's our function. Now to put it in parametric mode to simulate the pop-up. So now to simulate the pop-up, I actually want to see the ball going up and coming back down. So the x is now not going to represent time, it's going to represent the horizontal position. So I'm going to pick an arbitrary number, let's say 2. The y is still going to be this function, so I'm just going to take this, and that's going to be my y. So if I was asking you just to write this, that's what you would write. That would be your parametric function that would show me that pop-up. What that looks like in your calculator is this. So let's get our calculator out. I'm going to go press mode. So click on mode. Then I'm going to go down, scroll arrow down, 1, 2, 3, and arrow over to PAR for parametric, and then press enter to select it. And then I'm going to go to the y equals screen, and you'll see the y equals screen now looks a little different. Oops, there's some stuff there from another problem, so I'm going to get rid of that. And the x is just 2, so I'm going to go ahead and put 2 for x. The y is negative 16. Remember, you're pressing x, this button, the variable button, and it will give you a t instead of an x because it knows you're in parametric mode. So t squared plus 80t plus 5. And enter to put it in, and there's my parametric equation. For my window, I'm going to click on my window. So t is the time, and for this particular problem, it said we're just going to simulate the pop-up. So I don't know exactly how long the ball is going to be in the air, so I'm going to guess, and then I might have to adjust. So let's say maybe 10 seconds. It seems like a long time for a ball to be in the air. The t step is telling, remember, how often it's going to plot points. So right now it's set to every 0.1 seconds to plot a point. So in terms of our little cute animation that we're doing, this is going to determine how fast it goes. So I'm going to put it at 0.1 and see what happens. We might have to adjust it. The x value, in this case, we're just plotting 2, so my window just needs to make sure it shows 2, so maybe I'll go from 0 to 3 by ones. Not that important in this case, as long as I can see the x in there. And my y's, I know I want to start at 0, because that's the ground. I want to go up. I'm not exactly sure how high this ball is going to go up. I don't think a baseball is going 1,500 feet in the air. So maybe let's try 200 feet. That even sounds like a lot, just intuitively, but we'll see. And I'll change my scale to 20, just to see what that looks like. And so let's go ahead and graph. And I can see the ball going up, reaching its highest point, and coming back down. So that actually looked pretty good. Notice that it's still graphing, because I said to go from all the way to t equals 10. So it took a lot less than 10 seconds for it to come back down, so it kept plotting. So if that goes for a really long time, remember you can press like if you had pushed like 0.01, here I'll show you what this looks like. I'm going to show you everything, I might as well show you everything. So if I had 0.01 as my t step, that's going to be way too slow. So I press graph, and now it's going, oh my goodness, this is way too slow. So if I want to stop it so I don't have to wait for it to be done, I see the little worm is acting away here, right up there. I can just press the on button and it kills it. That stops it. And then I can go back to my window and set the t step to what I wanted it to be, 0.1. Okay, so we go ahead and graph it, and there it goes. Now I want to calculate the maximum height of the ball. Well, if you're in parametric mode and you don't feel like going back into function mode, You can find or you can approximate the maximum height of the ball using trace. Now this is only going to be as accurate as your t-step. So if your t-step was like 1, every 1 second it was plotting, then your trace isn't going to work very well. Our t-step was 0.1, so it's going to go up by 0.1 seconds every time, so that should hopefully give us a pretty good estimate. So I press trace. Notice my t starts at 0, and I get x and y values. And as I go to the right, I know it's weird that I'm making the thing go up by going to the right, but left and right makes the t value go up and down. So that's why we're clicking to the right. And this is also helpful because I can just see, okay, at 1.5 seconds, it's getting close, getting closer, getting closer. I'm looking at my y values to see, are they still going up? There's 101, 102, 103, 104, 104.8, 105, and now went back down. So 105 seems to be the highest point, and that was at t equals 2.5. So the maximum height of the ball occurs at 2.5 seconds after it was hit, and it's a maximum height of 105. So that's how you could use it in parametric mode to do that calculation. I'm going to go ahead and put that in there. So 105 feet would be the maximum height, and if I had asked you, that was at 2.5 seconds. And that is how you can use your graphing calculator to do parametrics. That's all for now. Thanks.